evening, friends. Today I discuss the laws of thermodynamics. The Zeroth Law. Zeroth Law. Zeroth Law of thermodynamics. Zeroth Law. If a body C is in thermal equilibrium with another body A and B, then A and B in thermal equilibrium with each other. Look, if A and C in thermal equilibrium, yeah, that's right, and B and C are in thermal equilibrium, then A and B are also in thermal equilibrium. This is the first law of thermodynamics. This is the first list of zeroth law of thermodynamics, and the second one is first law of thermodynamics. The first law of thermodynamics is a law of conservation of energy. State that the total energy of an isolated system is constant and energy can be transferred from one form to another, but cannot be neither be created or not be destroyed. Let's see that. Yeah, that one. The energy of system. The delta E. Delta E is the energy of the system. Is equal to the Q plus W. The Q is a work done on a body, on a system as well. And Q is the heat. Heat absorbed by the system. There is a system where Q is given and work done on system. Yeah, that's right. This is the first law of thermodynamics. In first law of thermodynamics, there is two functions. First is state function. First is the state function. The state function, that is, the state function is a property and describe a particular state without depending on path taking to that state. It not depend on the path of the system, path of the state. not depend on the that's right. Not depend. Yeah. It not depend on the path of the state. I will explain in later quickly. And second one is the path function. Path function. The path function is a property or a quantity which those values depend on composition of system from initial state to final state. It depends on the path. It depends on the path of state. Let me explain. Suppose this is a one state where pressure is 1 bar and temperature is 27 degrees Celsius and volume is 10 liter. Okay. It's changed to P2, P bar, T is equal to, where temperature is increased 27 degrees Celsius and volume is 10 liter. Yeah. In another state. The internal energy. This is an internal energy. This A is UA. Let take another system. Pressure is 1 bar. Temperature is 27 degrees Celsius and volume is 20 liter. Yeah. And this is an internal energy UB. We can go from that way to that way. Yeah. The path function is not in, and this is also a UC, internal energy UC. The path function where the internal energy is a the internal energy is an extensive function. Yeah, it is extensive function which are taught in earlier class. It is extensive function. And there's a energy, and there's a heat is QA, and there's an energy QB, and there's a energy QC. In path function, QA plus QB is not equal to QC, because Q is an extensive property. Path function was depending on the path of state. This one. If you go that way, this is not equal to that way. A plus B not equal to C in path function. But A plus B is equal to C in state function. State function does not depend on the path. And W is also an intensive property. Yeah. In state function, the state function QA plus QB, QA plus WA plus WB plus WB is equal to WC plus WC in state function. That is UA plus delta UA plus delta UB is equal to delta UC. This is and this is all and QT is a total QT is a total internal energy. Total internal energy. Right. State function can be go from 1 to 3. In state function you can go from anywhere 1 to 3, 1 to 2 to 3. In phase state function you can go from 1 to 3 or 2 to or 1 to 2 and 2 to 3. It does not depend on the path in that state function. Yeah, in the state function it does not depend on path. But path function is depending on the flow of process. And in first law of thermodynamics, there is a phase rule. Phase rule is a formula that is degree of freedom. The degree of freedom is equal to the number of chemical species minus number of phases in a system plus 2. The F is equal to C minus pi plus 2. This is a phase rule. In phase rule, let me take an example. Water in equilibrium. The chemical species is 1 minus phase. Phase is vapor and liquid. 2 plus 2, that is 1. The degree of freedom in water in equilibrium is 1. And let me talk to the states. Let me explain and further. In the first law of thermodynamics, there is a principle. There is a principle of conservation of mass. Conservation of masses. In principle of conservation of masses, the total mass entry in a control volume. I will explain further later in that what type of volumes is present, what type of system is there. I've taught you earlier class. There is a closed system, open system, and there is it. There is a control volume. In that control volume is also in existence there. The total mass entering in control volume is equal to the total mass leaving in control volume. In control volume. Yeah, there is a minus. The total mass entering in the control volume minus the total mass leaving in the control volume is equal to the net change in mass within the control volume. Yeah, there is a delta m in. Delta m in is a delta m out, and delta mv, delta mcv. Yeah, this is it. And this is it. This is it.